I'm using this as a sort of tryout for a talk I'm giving at the Metropolitan Museum of Art in May. You know, this year is the quincentenary of the year in which this famous engraving appeared by Albrecht Dürer. And Albrecht Dürer was quite a reasonable mathematician at the day. The things shown around here are various mathematical instruments, but what interests me at the moment is this magic square in the corner, which you can't read terribly well. By the way, I should thank Siobhan Roberts for many things, but one little one is producing these copies of the engraving. So this magic square was produced in this engraving was produced in 1514, and those two numbers are the two numbers in the middle of the bottom row, and they're outlined in some way so that it's clearer on the original engraving than it is here, so that you can tell the date this was produced. And you might notice, if you subtract 500 years from today's year number, you get 1514. So we're celebrating the 500th anniversary, the quincentenary of the production of this famous thing, which is called Melancholia I. Melancholia is the old name for clinical depression. And in those days, the days before Prozac and so on, clinical depression was really, really serious, and you could actually die of it. This figure on the engraving is called, by some people, a self-portrait of Dürer, but then others refer to it as the female figure in the engraving. I think that's just a question of the funny style of dress there. But anyway, here's an interesting question. Sort of historical problems about magic squares. What I'm going to do is not say anything more about the history of magic squares, but sort of tell you how to draw one of each order. The order is the number of squares per side. A 3x3 magic square has order 3. The 3x3 magic square can be described in many ways. It's traditionally called the Low Shu, which is the Chinese name for it. And there's a nice, entertaining legend about an emperor who was sitting on the side of the Yellow River when a turtle with this figure on its back rose up and became visible. But anyway, I'm going to sort of give a rather unusual way of describing it. In the middle cross, you write the odd numbers in order, in ascending order, and the corners you write the even numbers in descending order. I'll give you another and rather more familiar way of getting the same square in a moment. Okay, well, in the recreational math books, this is commonly called de la Lubbers Method, because de la Lubbers was the first French ambassador to Siam, and he came back and wrote an entertaining little book about what happened, Eastern customs and so on. And I mistakenly thought, oh, well, it shouldn't be called de la Lubbers Method if he found it somewhere else. So I thought it should be called the Siamese method, but I've learnt recently that he actually didn't learn it in Siam. He learnt it from a man on the boat coming back who brought it from India. Anyway, I call it now the step up or drop method. What you do is you start in the middle of the top row, and if you can, you step up, diagonally upwards. Well, you can here, because this is a torus we're writing it on. So I step up to here, and then it comes down to here. And then we keep on stepping up. But every now and then we get a place where we really can't step up, not because we've come to the boundary of the square, because the square has no boundary, it's a torus really, but because we've already filled the appropriate thing. Well, when we can't step up, we drop. And then we carry on 10, 11, 12, 13, 14, and so on. You might like to sort of draw some squares on your paper and learn how to do these things. This step up or drop method works out on for any odd order magic square. There are some other nice ways there are lots of methods of drawing odd order magic squares. And oh, by the way, I want you to notice this moon name on this piece of paper. I wonder what that's all about. Here on the Venus list, I'm going to show you a method I learned from a book about the turn of the century, the 20th century, on magic squares, and I wish somebody would tell me what it was. I call this the odd diamond method. You write all the odd numbers, I'm slanting them rather deliberately, in this diamond. Okay, in the usual sort of order. But then you write the even numbers down here. 2, 4, 6. Again, the square is really drawn on a torus. 8, 10, 12. And I've only got a limited amount of time, so I have a feeling I've just slightly missed this one. But anyway, you write the odd numbers up here, the even numbers in the other half of this square, the other diamond into which we've cut our torus, and that gives another magic square. I think this is one of the nicest, and it's not generally known. This I call the crisscross method. What one does is one draws a cross. This is when the square has doubly even side, in other words, a multiple of 4. You do a crisscross. Well, I'm just doing it for 4 at the moment. But then on the numbers that are not crossed off, you write the numbers from 1 to 16 in this case in increasing order. So I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then on the ones that were crossed off, I'll write the remaining numbers backwards. 16, 15, 14, 13, 12, 11, 10, 9, and so on. And that gives a magic square of order 4. I won't complete it. Perhaps I'll just draw over here. By the way, this is the Jupiter square. I haven't filled this all in. 2, 3, 5, etc. But then if one swaps these two columns, we obtain the magic square that Jura had. So this is, I'll call this the Jupiter square, and this the Jura square. I think this is probably the way that Jura found his particular square. I don't know that. Okay, so that does 4. If you want to do an 8 by 8 square, you do the same sort of thing, except that you put this crisscross in every 4 by 4 subsquare. And then you start off reading, in the non-crossed off squares, you enter the numbers in the usual order. And in the crossed off squares, then you go back and come down from, let's say, 64 all the way down to 1.
John, you have about 5 minutes.
Okay, oh, that's lovely, thank you. So I've told you now how to draw a magic square of any order that is not singly even. Singly even means twice an odd number. And twice an odd number has messed people up for a long time. It's really hard to draw a magic square whose order is twice an odd number. And the best method, the easiest method to do it, due to our theme. I'm sorry, that may be unthemely behavior on my part to refer to myself. But anyway, I call it the Lubbers method. Down here at the bottom, I've drawn in, these are 2 by 2 squares, and I'm going to put 4 numbers therefore in each square. And in the center of each square is a stylized L, rather slanting, or a U or an X. And what you do is you fill you have rows of L's down to and including the central cell, and then 1 row of U's, and then fill out the remainder with X's. This is rather small, we only have room for 1 row of X's, but anyway. And now, if and then we also interchange the L that should have gone into the central square with the U below it. So that's why these 2 squares are outlined. So now, what you do is choose your favorite method for an odd order square, and then you duplicate it like this. So I'm going to take the de la Lubbers method, or the step up and drop method, and so whenever I see an L, I fill it in this order down here. I walk down the L, that only occupies 3 numbers, and then I put the 4 up at the left. Whenever I say U, I just walk around it. An X, I do 5, 6 slanting down, and then 7, 8 slanting up. So I've already done a few of them. Here was 9, 10, 11, 12, because this was a U. Now I'm walking up to here, stepping over the border, and doing 13, 14, 15, 16. That's an L, and in the same way, 17, 18, 19, 20. And now I have to drop, and so it'll be 21, 22, well, 23, 24, and I'll leave it as an exercise for you to complete this 10 by 10 magic square. So what have we done? I've done doubly even, I've done odd in 2 different ways, and now it comes, I've done singly even. Oh, so I've done them all. Okay, that's very good. But now I'm going to try to explain this business about all these heavenly bodies that are going around. This is a very interesting thing. All the old writers on magic squares associate 3 by 3 squares with Saturn, 4 by 4 with Jupiter, 5 by 5 with Mars, and so on. Well, there's a funny thing about the order. The order of these planets, and I'm including the Sun and the Moon in that, is what I call the dignity order. Saturn takes about 30 years to go around the Sun, and equivalently to go around us. Jupiter takes about 11 years. Mars takes about 3, and so on. So the order of descending order of dignity is written on this thing here. Why they attach these numbers to magic square, why they attach these gods, planets, to magic squares, I do not know. And the old authors, by the time it gets to be about 16 something, they already say they don't know. But there's a really interesting connection with days of the week. The days of the week are named after the same thing, except in a different order. Saturn, Saturday. Sunday. Monday. Moon day. Now we switch into French, just for a moment. Mardi, mercredi, jeudi, vendredi, and then we come round to Saturday again. We get a lovely start. Now, I will just briefly explain this. The traditional story is that each of the 24 hours was dedicated to one of these bodies or gods. And so that means in 24, and the next hour is dedicated to the next one round in this dignity order. So if the first hour of a day was dedicated to Saturn, then 24 hours later takes you 3 times round this cycle, that's 21 hours, and 3 extra ones. So the first hour of the next day will be devoted to the sun. Oh, why is it the sun here? It's really we're doing it geocentrically. So we don't think of the Earth going around the sun, we think of the sun going around the Earth. So in the place of what you would think of as the Earth nowadays, you have the sun. Okay, that's all I have to say.
Thank you, John.